Alright. So most of you were absent. There were only 32 students contribution. What happened? Together there were only 32. Hmm? Okay. All right, students. A very good afternoon. We'll be starting unit number 5 in this class today. So unit number 5 comprises of cylindrical pressure vessels, columns, and combined stresses. Okay, we'll start with the first half of unit number 5, that is cylindrical pressure vessels. The students, we come across many cylindrical pressure vessels in our day-to-day life. For example, one of the common example is a LPG cylinder. Friends, have you seen LPG cylinder? Most of you might have seen it. See, LPG cylinder has to be designed and the material has to be used in such a way that it has to withstand the pressure that is built inside. The LPG, if you open the knob of the LPG cylinder, the gas will leak from there. It comes to the burner and then it burns there. So it will come with some pressure to the burner. So as soon as you open the knob, it will leak, isn't it? The gas leaks down. So there it has to be filled with some pressure and stored with some pressure inside, and the cylinder material has to withstand that pressure, is it? So this is one of the real-time example that we do. And then we have another example, like for example, let me take it as a steam boiler, students. So in steam boiler, what happens is there will be a drum type arrangement at the top of the furnace, wherein water will be boiled to form steam. So after formation of the steam, it it builds up some pressure inside that cylinder. It builds up some pressure inside the boiler. So the boiler has to withstand that pressure. So engineer has to design. So as a design engineer, we have to design that boiler in such a way that it has to withstand that pressure, isn't it? So uh, for that purpose, what will be the considerations and what will be the possible failures and how to calculate the stresses induced in those pressure vessels? This is all we'll learn in this chapter, students. And then we can also take an example of a water pipe. All right, there will be water flowing from one area to other area through pipes, wherein it has to taken away with some pressure. All right. So let me take the running example like Polavaram. Polavaram, there is a diversion of the river from one position to other position, wherein this diversion has to happen by means of huge channels of pipes. All right. Those pipes have to withstand the pressure induced by the flow of the water. So for that purpose, the engineer has to design the material of the pipe or the size of the pipe. Size and material matters here, and cost matter is also one of the things that we have to concentrate as an engineer. So based on all these criteria, the engineers will design like how much pressure will be induced, how much stresses will be induced, and what kind of design can withstand this. Well, it should come for a life, right? The steam boiler that we have taken as an example, or the LPG cylinder, it has to withstand that pressure. If we make it with a very low strength cylinder, it will burst out. All right, it will burst out, which does not mean our purpose. So students, that is why we study cylindrical pressure vessels. This is like a different thing from the civil engineering students. All these things that we have studied so far will also be studied by civil engineers, but this pressure vessels is not included in civil engineers syllabus. But this is required for us. Okay, this is required for mechanical engineers. So cylinders are classified into thin cylinders and thick cylinders, students, based on their thickness and diameter ratio. Based on their thickness and diameter ratio. So let me show you here, students. based on their thickness. All right, based on their thickness to diameter. Thickness to diameter ratio. If thickness to diameter ratio is greater than 20, then we call it as thin cylinder. Thin cylinder. And if thickness to diameter ratio is less than 20, then we call it as a thick cylinder. Okay. So mechanical engineering, for designing purpose, the engineers have classified cylinders into two types. Those are thin cylinders and thick cylinders. I hope you got these, students. Alright. So thickness in the sense, for example, if you take a cylinder, it will be like this, right? It will be like this. So this is thickness, right, students? This will be thickness. Alright. So if this thickness to diameter, okay, thickness to diameter ratio, if it is greater than 20, then we call it as a thin cylinder. See, for example, if thickness is some 5, uh, sorry students, let me take this as in opposite direction. Okay, all right. And we can also say this, students, diameter to thickness ratio greater than 20 is thin. So don't get confused, students. There will be lots of bits based on this also. So I have also got confused. Uh, is it clear now, students? So let us see if the thickness is 5 and the diameter is 20, and it will be 1 by 4, right? So which is less than 20. So that will be a thin cylinder. Okay. And if you assume, let us take this into our consideration, students. Don't get into this. Diameter to thickness greater than 20 is thin cylinder. Diameter to thickness less than 20 is thick cylinder. Okay. Okay. So there were 50 students now. I'm happy. Alright. So students, we were discussing about cylinders, cylindrical pressure vessels. Uh, as I have said, cylindrical pressure vessels have some day-to-day applications like LPG cylinder, steam boiler, and water pipelines or gas pipelines, whatever. So based on the pressures induced by the flow of the fluid inside, the designer has to design to withstand the pressure that is developed there. So the designer has to choose the material for that pipe, choose the material for that cylinder in such a way that it has to withstand that pressure. Okay. So for engineering analysis purpose, the cylinders are classified into two types. The cylinders are classified into two types. They are thin cylinders and thick cylinders. Okay. So thin cylinders and thick cylinders. When do we call thin cylinder is if the diameter to thickness ratio is greater than 20, we call it as a thin cylinder. Is it clear, students? So let me take out an example, students. If the diameter is 50 mm and the thickness is 5 mm, this will be some 5 by 50 by 5 is 10, right? So this comes under thin cylinder. Okay. And if the diameter is some 100 and if this is 5 or some, let me take this as 15. Okay. So this will become some 6 point something, right? So this is also less than 20, so 6 cylinder only. uh, all I am giving is examples for 6 cylinders. Anything? Okay. Why only 20 is because the ASM is standard. It is a standard given by some engineering society. That's it. It is not mandatory that we have to take 20, but some textbooks have taken it as 10 also. Some textbooks have taken this ratio as 10 also, and some people take this ratio as 20. In general, most of the engineers follow will this rule. Follow In general, most of the engineers will follow this rule to classify cylinders. So for classification of cylinders, I have taken this as my criteria. So the criteria is diameter to, so this is diameter, students, diameter to thickness. Okay, this is thickness. Diameter to thickness ratio, if it is greater than 20, we call it as thin cylinder. If it is less than 20, we call it as thick cylinder. This is very important, students. Most of the times it will be asked in competitive examinations also. Is it clear here so far? Any disturbance? Any doubts? Okay. All right. Clear. So let us talk about thin cylinders first, students. Let us talk about thin cylinders, and then we'll go into thick cylinders. Thin cylinder. So thin cylinder, as the name implies, students, thin ante thickness will be very very less. Okay, d by t will be greater than 20 for thin cylinders. As the name implies, thin. I hope you are all seeing this. Thin cylinders, and d by t ratio will be greater than 20 for this thin cylinders. థిక్ సిలిండర్స్ అంటే థిక్నెస్ కొంచెం ఎక్కువ ఉంటుందని, థిన్ సిలిండర్ అంటే థిక్నెస్ కొంచెం తక్కువ ఉంటుంది. ఓకే, let us talk about this thin cylinder, students, and then we'll go into thick cylinders. Let us consider cylinder, students, like this. So let us consider a cylinder like this, and let us assume there is a flow inside. All right, flow inside. Okay, there is a flow inside. So because of this flow will induce some pressure, right? Pressure on the walls of the cylinder. There will be pressure on the walls of the cylinder. We can assume it to be open at both ends, or we can assume closed at both ends also, students. అంటే సిలిండర్ అంటే ఫ్లోనే ఉండాలన్నా సార్, పైపే ఉండాలన్నా అట్లేం లేదు. We can also assume that both sides are closed. Even if it is both sides are closed, there will be application of pressure like this over the walls of the cylinder. All right. So because of this application of the pressure, there will be circumferential stress. Circumferential stress. Okay. Circumferential stress, we call it as sigma c. Circumferential stress is also called as hoop stress, sigma h. Okay. And again, because of this application of pressure, this pressure will also induce longitudinal stress. Longitudinal stress, that is denoted by sigma L. Is it clear, students? So let me take over for the side view. So if you see the side view like this, so this will be the thickness of the cylinder. This will be the thickness of the cylinder, and assume there is a flow. All right, assume there is a flow, or else it is a closed one only. Okay, or else it is a closed one with some pressurized fluid inside this. So because of this pressure, there will be circumferential stress. Circumferential stress in the sense, if this is the cylindrical wall, it acts over the surface like this. All right, it will be over the circumference like this. Throughout the circumference, there will be circumferential stress like this. Okay, on the periphery like this. So on the periphery of this cylinder, there will be circumferential stress. We can also call circumferential stress as hoop stress. Hoop. Okay. Hoop stress. We call this as hoop stress or circumferential stress. Circumferential stress. And there will be longitudinal stress as well. Longitudinal stress as well. See students, for this I would like to say you an example. Imagine a pipe, students. I hope my pen is visible, right? All right. So imagine a pipe in which water is flowing. So assume this is a pipe wherein water is flowing. So because of the application of the fluid, this pipe will enlarge. Because of the application of the fluid pressure, this pipe will enlarge. Enlarge in the sense it will make the circumference or the diameter to enlarge. Alright. సో ఇప్పుడు ఇది పైప్ అనుకుంటే దీంట్లో మనం వాటర్ పంపిస్తే, ప్రెషరైజ్డ్ వాటర్ పంపిస్తే ఏం చేస్తుంది అంటే ఫస్ట్ ఈ పైప్ సర్ఫేస్ని లావ్ చేస్తుంది, అంటే ఉబ్బుతుంది. అవునండి. మనం అబ్జర్వ్ చేస్తే ఎప్పుడన్నా చేన్లలో అంటే ఫార్మ్ ఫీల్డ్స్లో వాటర్ పెట్టే పైప్ ఉంటుంది కదా, ఏం వాటర్ లేనప్పుడు ఫ్లాట్గా ఉంటుంది. వన్స్ వీ సప్లై వాటర్ ఇట్ విల్ మేక్ ద పైప్ ఎన్లార్జ్, అట్లా లావ్ అయిపోతుంది. అంటే దాని ఎక్స్ట్రీమ్ ఎంతవరకు ఫిట్ కాగలదో అంతవరకు ఫిట్ అవుతుంది. రైట్. దట్ ఈజ్ నథింగ్ బట్ ద సర్కంఫరెన్షియల్ ఫోర్స్ దట్ ఈస్ అప్లయింగ్ బై ద ఫ్లూయిడ్ ప్రెషర్. అంటే ఫ్లూయిడ్ ప్రెషర్ వల్ల సర్కంఫరెన్షియల్ ఫోర్స్ అప్లై అవుతుంది. And to restrict that circumferential force and to withstand, the material will offer some stress. I am calling it as circumferential stress. Is it clear, students? So stress is nothing but the opposite force induced by the material of that material to withstand that pressure. అంటే మనం అప్లై చేసే ఫోర్స్ని విత్స్టాండ్ చేయడానికి మెటీరియల్ ఒక రెసిస్టెన్స్ ఆఫర్ చేస్తుంది. ఆ రెసిస్టెన్స్నే స్ట్రెస్ అంటున్నాను. అలాగే ఇప్పుడు పైప్ కానీ సిలిండర్ కానీ మీరు ఏదైనా అజ్యూమ్ చేసుకుంటే, ఇన్సైడ్ ఇఫ్ దెర్ ఈస్ ఏ ప్రెషరైజ్డ్ ఫ్లూయిడ్, then the circumference will offer, the material on the circumference will offer certain resistance to the pressure applied. So that resistance is called circumferential stress or hoop stress. And then there will be longitudinal stress as well. So assume the same pipe, students. Assume the same pipe. So because of the fluid flow, there will be longitudinal stress like this. So if I tangentially expand this pen like this, all right, if I tangentially expand this pen like this, it will break at the center part like this. Under two halves, it will become into two halves. See, uh, the pipe will break down like this because of the application of the tangential stress. Okay. So this is failure, students. See, you have to understand this. There will be two kinds of failures: tangential and circumferential. Longitudinal and circumferential. To overcome these failures, the material will induce stress. Is it clear, students? I hope you are very clear about the applied load, stress, and failure. Any doubts here, students? The fluid will apply some force to the material of the pipe or cylinder. To withstand that force, the material will offer some resistance. That resistance is nothing but stress. If the force applied is beyond the resistance, what happens? There will be failure. Is it clear? ఇప్పుడు నేను ఇదే పెన్ను తీసుకున్నాను, ఓకే, నేను అప్లై చేస్తున్నా. ఒకవేళ ఇది విత్స్టాండ్ చేసింది అనుకోండి, విత్స్టాండ్ చేస్తే స్ట్రెస్ వస్తుంది. ఇంకా నేను ఎక్కువ అప్లై చేస్తాను అంటే ఇంకా ఎక్కువ చింపుతున్నా, ఇంకా పూర్తిగా ఉంచేస్తున్నా, అప్పుడు ఏమవుతుంది? సో ఇఫ్ ఇట్ రీచెస్ ద withholding capacity, it will break down, it will fail. So there will be two types of failures: circumferential failure. So in circumferential failure, the cylinder, what happens to the cylinder is, so if this is the cylinder, in circumferential failure, the cylinder will break down like this. Alright. అంటే టూ హాఫ్స్ అవుతుంది, అంటే టూ ట్రఫ్స్ అవుతుంది. టూ ట్రఫ్స్ ఇన్ ద సెన్స్ బికాస్ ఆఫ్ ద సర్కంఫరెన్షియల్ strain or pressure, the cylinder will break down like this. Alright, this is one, and another half is this. Alright, is it clear, students? So it will break down like this. Whereas this is circumferential. Okay, so here this will be like this. There will be application of force like this. Okay, everywhere, and because of this pressure there will be circumferential failure, and not to make this fail there will be stress induced by the material or stress offered by the material, that I am calling it as circumferential stress. And if you see the uh, if you see this will be longitudinal, students. So in longitudinal it will break down into two parts. Okay, this is longitudinal. This is longitudinal failure. Here, the pressure will be induced in this way. Alright, the pressure happens in this way because the fluid will flow and there will be closed. This will be closed and this will be closed, and because of this, the pressure on these two plates will make this to break longitudinally like this. Alright, so this is longitudinal stress here. So if it withstands not to fail, if it withstands not to fail, then the stress is longitudinal stress, and if it withstands not to fail in circumferential failure, the stress is called hoop stress or circumferential stress. I hope you are clear, students. Any doubts here? Let me know if you have any doubts here, students. Okay. All right, so these two things, students, if you understand very carefully, we have to solve derivations for these. So for longitudinal stress we have to derive a equation, and for circumferential stress we have to derive a equation. And what are these longitudinal stress and circumferential stress uh, due to the cylinders, that we have to know. So based on this we can design the cylinders. So let us go with this, students. Let us go with thin cylinders. So thin cylinders, thickness to diameter to thickness is students, you have to remember this, students. This will be always d by t greater than 20. You have to remember this way only, and if you remember this way, this will be t by d less than 20. Okay, do not go with the students because this will be confusing. So d by t, if you remember this d by t is greater than 20, then you can make it anyway, even if it is a reciprocal there in your examinations. మీ ఎగ్జామ్స్లో ఒకవేళ కాంపిటేటివ్ ఎగ్జామ్స్లో ఇది రివర్స్ చేసి అడిగినా కూడా క్వశ్చన్స్ మీరు చేయగలరు. So remember only one thing, students. Don't go for two. Okay. Uh, Now consider half of the cylinder of length L sectioned through a diametral plane as shown in figure, and let us consider this, students. So I have already taken this. Let me drag it over there. Okay. Okay. So I have no option to zoom. Huh? All right. All right, students. Let me draw this. Okay. I thought I can zoom this, but no, it's not happening. So let me draw this. That will be an easy task. Don't worry. So we'll be having like this. No, no. First, wait. I'll just take it from there. Yeah. All right, students, is it okay for you? This is the thing that we have discussed now. So here there will be hoop stress, students, and this will be longitudinal stress acting over the cylinder like this. So let us consider a cross section of a cylinder on which there is a pressure P and thickness of this cylinder be T. Okay, small t, students. So this is T and this is D and this is pressure P. And if you can also observe the hoop stress acting over here like this. Alright, hoop stress acting over like this. Now let us write the equilibrium of forces in vertical direction, students. Equilibrium of forces, equilibrium of forces in vertical direction. Okay. So in vertical direction, there are forces acting. So let us see what are the forces, students. Here we have stress in vertical direction, and here we have P force in the vertical direction, isn't it? So this is P is pressure, students. P is pressure, and sigma H is hoop stress. Okay. So in the vertical direction, we have hoop stress and pressure, right? We have hoop stress. Is it clear, students? There is hoop stress acting here, and if you see this, there will be a strip like this here. I will draw the bottom part, students, for your convenience. Is it? So this part, student, this strip and this strip. Okay, please cleanly observe this. There will be strips like this at the top end also, right? So this hoop stress, this entire hoop stress will be acting over these strips. Is it clear? So if you imagine this in a round one, if you imagine this as a round, if you imagine this as a round, students, okay. So this part, at this part, the all hoop stresses will be acting at this. So if you, this is the front view, students, and if you go to the side view, you can able to see the entire length of the strip. Is it clear? This plays an important role, students. You should be knowing this. I hope it is okay for you. All right. So this all this hoop stress will come and stand over here. Now our task is, let me start with the basic, students. We know that all the forces in vertical direction, we can make them equal. So here if you see, the pressure is acting in another direction and the hoop stress is acting in another direction, that we know. So this is because of the application of the load, and this is the resistance. So this is application of load and this is the resistance. They both will act in opposite direction. As the material has to be in equilibrium, the material offers that stress. So that is why they both will be in opposite direction. So let us write this, students, very basic one. Equilibrium of forces in vertical direction, that will be uh, resisting force resisting force is equal to resultant vertical pressure force. Okay. So there is pressure applied here. Because of this pressure, there will be force acting. So pressure is nothing but force per area. Pressure is nothing but force per area, and there will be resisting force offered by the material. So I have equated both of them. All right. So now let us see what is resisting force, students. What is resisting force? Resisting force, in a sense, stress multiplied by area kada. Stress is circumferential stress. Circumferential stress multiplied by area. Area. ఏరియా ఏమన్నా రాయొచ్చు, రెసిస్టింగ్ ఏరియా అని రాయొద్దామా? ఓకే, resisting area is equal to resultant vertical pressure force. So where is the pressure acting? So pressure is acting here. So pressure alone will not give us force. Pressure multiplied by area will give us force. Pressure multiplied by projected area, projected area of that pressure. So this pressure is applied over this, and the projected area will be D multiplied by L. Is it? Is it clear, students? So circumferential stress, I just give this as sigma h. Okay, resisting area is resisting area. So circumferential stress will be acted upon these two strips, right? These two strips. What is the area of this strip, students? This is a rectangle. This is a rectangle, and this is thickness T, and this is L. So L into T is the area, right? There are two things, two strips. So L into T multiplied by 2 will get area of the resisting area. So into 2LT is equal to pressure is P, that is what we are applying, and the projected area on which the pressure is applied is nothing but D into L. Is it clear, students? Now sigma h can be written as L will get cancelled. So PD by 2T, PD by 2T. So this is very important formula, students. This is very important formula. I hope everyone understood this. If you have any doubts here, please let me know, students. So what I have just taken is I have come from the basic. Okay. Solid. I have come from the basic, students. So there is a pressure applied like this. So this pressure P will induce some force. Alright, will induce for some force. So pressure is acting upon this contact area. So this contact area, so this projected area, that area is nothing but P into dl. I have taken this as force that is applied, and this is equated to the resisting force. Resisting force is nothing but stress multiplied by the area on which the stress is acting. So this is the area, students, on which the stress is acting. So this area is, if you see this strip is a rectangle L into T area, and this is also another rectangle L into T. So L into T plus L into T is 2L into T, and the stress is sigma H. So sigma H to LT. So if you remember this, if you equate this, I have just equated two forces and I have derived sigma H. Is it clear? Everyone okay with this? Everyone okay with this, right, students? Shall we move into longitudinal stress? All right. So let us move into longitudinal stress, students. See, longitudinal stress, if you assume this, if you assume a cylinder like this, so all right, if you assume a cylinder like this, students, so the pressure will be moving in this direction. Okay, assume the fluid itself is flowing with some pressure in this direction. So there will be stress which opposes this application of force. That stress is nothing but sigma L, longitudinal stress. Alright. So if there is movement in this direction of the fluid, then there will be opposing force, opposing to withstand this pressure. This material will offer some stress that I am calling it as longitudinal stress. In the longitudinal stress, if this longitudinal stress fails, it will break at the middle and becomes into two halves. Alright. So here, if you see this, Same, we'll apply, consider the section cut by transverse plane here. So let us assume the section is cut like this, and let us write for forces, equilibrium of forces in longitudinal direction. There in the top, we have taken it in the vertical, equilibrium of forces in longitudinal direction. Okay, longitudinal direction. So longitudinal stress multiplied by resisting area, resisting area, okay, is equal to pressure multiplied by projected area. Okay, so I just wanted to make two forces, students, so let me do this again. Okay, there is a pressure acting over like this. Okay, this is all the area on which the pressure is applied like this. So the fluid will be flowing like this. And here, if you observe this, and if you otherwise you just take a section and draw this. So the longitudinal stress will be on this area, and uh, sorry, I'll make it okay, I'll make it in a 3D view. Okay, so the longitudinal stress will be on this part like this, in this direction, and pressure will be acting all over this area. Okay, so if you write the equilibrium, longitudinal stress is sigma L, resisting area is this is 2 pi r, right? This is 2 pi r into 2 pi r multiplied by t, అంతే కదా. అప్పుడే మనకి స్ట్రిప్ ఏరియా వస్తుంది. ఇదిగోండి, ఈ ఏరియా రెసిస్టింగ్ ఏరియా అంటారు. అలా ఇక్కడ ఉంది చూడండి, ఇది దిస్ ఏరియా, ఆల్ దిస్ ఏరియా ఇస్ ద రెసిస్టింగ్ ఏరియా ఆఫ్ ద లాంగిట్యూడినల్ stress is equal to pressure applied multiplied by this area. So all this is done by the pressure. సో ఇక్కడంతా ప్రెషర్ది ఉంటుంది. సో ఈ ఏరియా ఆఫ్ సర్కిల్ కదా, అది ఏరియా ఆఫ్ సర్కిల్ ఏమని రాయొచ్చు, పై ఆర్ స్క్వేర్, ఇస్ ఇట్? సో ఐ జస్ట్ టేక్ స్మాల్ ఆర్ హియర్ ఆల్సో, 2 pi r into, okay. Is it clear, students? If you have understood this equation, we will move forward, and there is nothing to go there. And sigma L is equals to, we can directly write it as sigma L is equal to P, R gets cancelled, students. R gets cancelled. R can be written as d by 2, right? So P d, this 2 and the bottom 2 will be multiplied, P d by 4t. Okay, here we have 2, and here this R can be written as P pi R into d by 2 అని రాస్తా. ఓకే, అప్పుడు R క్యాన్సిల్ అయితే d by 2. ఓకే, P pi d by 2 ఉంటుంది ఆల్రెడీ. ఇక్కడ నుంచి 2t వస్తుంది. సో Pd by 4t అవుతుంది. సిగ్మా L is equal to, సో సిగ్మా H ఏముందండి, Pd by 2t. So we have sigma H is equals to Pd by 2t, and sigma L is equal to Pd by 4t. This is very, very important. These two formulas are very important. Okay, any doubts here, students? So if there is nothing, we'll be closing this class. Let me take the attendance. So the attendance is very, very slow, very, very low, students. This time there will be attendance criteria also. Probably there will be attendance criteria, and there will be details also, I guess.